Hi, so the topic that we are
That we are
going to
going
do
to do
now
now
is
is
acids and
acids and
bases.
bases.
And
And
you need to know the definitions, you need to know the basic reactions that we have for acids and bases, and then obviously how we make ionic equations from them and how we make salts for any particular solubility or precipitation. So let's start. Acids react with bases, carbonates, and metals. We know that. Which of these reactions produces a gas? Now we know that when acids react with metals, the H positive ion in acid is replaced by the metal ion. So there is going to be hydrogen gas being released. Similarly, when acid reacts with carbonate, it also produces carbon dioxide gas because the carbonate ion breaks down. But no other reaction that we have studied in O levels or IGCSE will produce gas. So that means that whenever you're doing this reaction, you either have a carbonate that you're doing a reaction with or metal that you're doing a reaction with acid so to produce gas. So that would mean you're going to go for C. In the next question, the position of elements W, X, Y, and Z in the periodic table are shown. Which elements form basic oxides? Again, remember that whenever you have oxides, so oxides are going to be divided by whether they're metal oxides or whether they're non-metal oxides. And within metal oxides, you have mainly the basic ones or the amphoteric ones. And in the non-metal ones, you have neutral ones or you have the acidic ones. Now, most of them are acidic. There's only three that are neutral. So that's carbon monoxide, water, and nitrogen monoxide. Similarly, most of the metal oxides are basic, but there's three that is amphoteric, which are aluminium, zinc, and lead. These are the three ones you need to remember that they're amphoteric. So, judging by this, we can expect W and X to be definitely basic, and then Y, as you can see, is in place of copper. So again, that could also be basic. So you just have Z left, which is non-metal, or even if it is not non-metal, it is in the region that is going for amphoteric. So we are going to go with W, X, and Y. Carbon dioxide is produced when dilute hydrochloric acid reacts with, so carbon dioxide is produced when a metal carbonate reacts with acid. So that's going to be copper 2 carbonate. Question number 4 says, which substance reacts with dilute sulfuric acid to form a salt? Now you need salt, and remember that salts are made when you have a cation and an anion. The anion with sulfuric acid is going to be sulfate. So you're looking for something that reacts with this as a base or as a metal. Now, out of the four options that you have, magnesium chloride is the one that is salt itself. So it does not react with sulfuric acid as a base or metal. So we are going to assume that with magnesium you're going to get magnesium sulfate, with magnesium oxide again magnesium sulfate salt, magnesium carbonate, magnesium sulfate salt, but not the case over here. So we're going to go with A. Water is added to a test tube containing dilute sulfuric acid of pH 4. What could be the pH of the resulting solution? Now, sure, dilution does affect pH to some extent, but we do not study that in O levels or IGCSE. So we're going to assume the pH remains the same at 4. A colorless solution is tested by the following reaction, which reaction is not characteristic of an acid. So for this, you need to first know what are the characteristic reactions of acid. So now the characteristic reactions of acids are that they produce hydrogen with metal, they produce carbon dioxide with metal carbonate, they produce salt with metal oxide or metal hydroxide. These are the four characteristic reactions of acid. So a piece of magnesium is added, bubbles are seen and magnesium disappears. This shows that metal is reacting with acid. So this is the gas being produced is hydrogen. A pungent smelling gas, which is usually ammonia, is produced when ammonium carbonate is added. Now, ammonia should not be produced with any acid because ammonia should react with acid and make ammonium salt. So, this is one option that we can consider. Copper oxide powder is added, which is, as you know, basic, and the reaction and the mixture is warmed. The solution turns blue, which means it reacts and produces copper ions. So, yeah, this is base reacting with acid. Solution turns blue litmus red. That's also acidic property. So this is going to be our option. The graph shows how the pH of soil in a field changes over time. At which point was the soil neutral? Now you have to understand how to read the graph. So pH is on the y-axis, so you have to see that neutral is when the line is horizontally at 7. So the only option we have is B, so that's going to be our answer. How many different salts could be made from a supply of dilute sulfuric acid? So you have sulfuric acid, dilute hydrochloric acid, copper, magnesium oxide, and zinc carbonate. Now remember that copper is below hydrogen in the reactivity series, which shows that it will not react with dilute acids. So you can't react it with copper, either of the acids. But you can react both of them with magnesium oxide, and you can react both of them with zinc carbonate. So which means you're going to get 4 different reactions, all of them producing salts. So your answer is going to be B, because you're getting 4 salts. But again, the question was not whether you're producing 4 salts. The question was, are you producing 4 different salts? So let's look at it again. Are we going to get any salt that has common anions? So we're going to get sulfate here and chloride here. So magnesium chloride, magnesium sulfate. Then we're going to get zinc sulfate, zinc chloride. All of them are different. So yeah, this is confirmed to be 4. Farmers add calcium oxide, which we know as slaked lime or lime, and ammonium salts to their field. So we know calcium oxide is basic, but ammonium salts are acidic. The compounds are not added at the same time, obviously, because they react with each other. Which gas is produced in this reaction? So when ammonium salt reacts with calcium oxide, it's going to produce some calcium salt and ammonia gas, because ammonium ion breaks down, gives ammonia gas. So it's going to be ammonia. Some reactions involving sodium are shown. Which reaction does not involve formation of base? Again, remember that with sodium, you're going to get sodium hydroxide, sodium oxide, sodium carbonate, all of them bases. So there's only one that is not base in this, which is sodium chloride. So C is the answer, because it produces salt, not base. Calcium hydroxide is added to neutralize the acidic solution formed after chlorine has been added. Okay, this solution contains hydrochloric acid. Write an equation for the reaction of calcium hydroxide with hydrochloric acid. So pay attention to your reactants. These are calcium hydroxide. Remember that the formula is going to be CaOH with 2 around OH, because OH is -1 but calcium is +2. So you need 2 hydroxides to cancel the charge on calcium ion. Similarly, with HCl you have this formula. Notice that a common mistake is students put C and L both capital, which is not the case. It is C capital and L as the small letter. So when they react, this is a neutralization reaction. Now, because you have 2 hydroxides, you will produce 2 water, and to do that you need HCl. So we'll balance it like that. Now they're saying write the ionic equation for this reaction. Now the best way is to understand that this is neutralization reaction. And neutralization reaction is when you take H positive ion reacting with hydroxide ion producing water. But let's suppose you don't recognize it as neutralization reaction. So how can you do it? So for that, remember that anything that is aqueous, you're going to ionize that. So this ionizes, this ionizes, this ionizes. This is a liquid, does not ionize. So when you do it, you'll get calcium ion, 2 hydroxide ions, 2 hydrogen ions, 2 chloride ions, producing 1 calcium ion, 2 chloride ions, and obviously 2 water, which is H2O, does not ionize. So calcium ion cancels, chloride ion cancels. The reason we are doing this is because these are spectator ions. So what you're left with is hydrogen ion, hydroxide ion producing water. I took the 2 out because it was just common in all of them. So you can just get this equation. Methylamine CH3NH2 is a base which has similar properties to ammonia. When a methylamine dissolves in water, the following equilibrium is set up. Explain why methylamine behaves as a base in this reaction. Now, going by the classical definition of base, that base produces OH minus ions, right? So as you can see over here, that this thing, when dissolves in water, it produces hydroxide ions. So that's what we'll write, that it produces OH minus ions. Carbon dioxide dissolves in water to form a weakly acidic solution. So there are two terms here, weak and acidic, and the question is also asking us about that. So remember that weak is anything that ionizes partially, and acid is anything that produces H positive. It's a 1 mark question, so it doesn't hurt to explain both of them. So what is the meaning of the term weak acid? It is a solution or a substance that produces H positive ions. So that is how you have defined acid. And then you're saying weak. So for that we'll say and partially ionizes. Or you could rephrase it in a way that makes sense to you, that a substance that partially ionizes to produce H positive ions. Or you could even just write weak acid, because it's a 1 mark question. So just by explaining what weak means here, you've answered the question. Describe how you could measure the pH of this solution other than by using a pH meter. Now this is a 2 mark question. So that means you have to make two major points here. Now how do you measure the pH? Usually we go by either the universal indicator or the pH paper. So let's say if I were to say pH paper, so I'll say that dip the pH paper. That's my first step. I've selected what I need and I have given my working. Now you could also write that add a couple of drops of universal indicator. Either of those would work. But then how would you know what the pH is? So then you say that match the color with pH chart. And that is something that many students forget, because sure, you see the color, but how do you know what pH it is? You have to match it to that value. So for that you have to match it to the chart that is usually given with the bottle or with the pH paper container. Sodium hydrogen carbonate decomposes on heating to form a carbonate, water, and a gas which turns lime water milky. So carbonate, water, and a gas which turns lime water milky, which is carbon dioxide. So let's say we have sodium hydrogen carbonate. It breaks down, makes a carbonate. So that's going to be sodium carbonate, obviously, plus water, plus carbon dioxide. Now when you're balancing equations, start with any element that is not hydrogen, not oxygen. So maybe I'll start with sodium. So I have 2 sodium on the right, so I'll just multiply this side by 2. Remember that you cannot change the formula. So the formula stays, and now you can see this is balanced. Suggest the color of the indicator in the following compounds. Now in litmus, sodium hydroxide being a base, it will give us a blue color, and carbon dioxide being an acid, it will give us a red color. The colors of methyl orange are red and yellow, red in acid, so that's going to be here, and yellow in base, so that's going to be here. Now this question is again a repetition, so I'll skip this one. Then it says nitric oxide in the atmosphere can chemically erode buildings made from carbonate rocks. Write an equation for the reaction of nitric acid, which is an acid, reacting with calcium carbonate. So calcium carbonate is limestone, usually available in many marbles, many rocks and all that. So calcium carbonate being a base will produce carbon dioxide and water with acid. And what you're left with is calcium and nitrate ions. So they'll react to produce calcium nitrate. Make sure that you write the formula correctly. Nitrate is a -1 ion and calcium is +2 ion. So now you can see that it is balanced if you write 2 here. So that's how you give your answer. A student adds aqueous sodium hydroxide from a burette into 25 cm³ of dilute sulfuric acid. The student measures the pH value of the mixture during the addition of sodium hydroxide. Describe how the pH value changes. Now, because you're adding a base, a strong base, to an acid, a strong acid, so while you do not know the exact values, you can still say how it changes and you have to describe it. So by qualitative description, we can say it increases, and that's good enough. Given ionic equation to represent the neutralization reaction, so they have specified what the reaction is, and you know that for neutralization reaction, you need H positive ion reacting with hydroxide ion making water, and that is the neutralization reaction. What is meant by the term acid? Acid is a substance that produces H positive ions. Now you can say that H positive ions in water, implying that all acids are soluble, but you can still do without it. What's the difference between strong acid and a weak acid? So because it's a question that asks you to differentiate, make sure that you write the differences clearly. You have to mention what the strong acid does and what the weak acid does. Just saying that weak acid does this does not answer it about the strong acid. So you have to clearly demarcate the difference. So strong acid ionizes fully, while weak acid ionizes partially. So I have answered the question. I do not need to mention what the acid does because I've already answered in the previous part. Dilute sulfuric acid reacts with magnesium to give hydrogen. So sulfuric acid reacting with magnesium. Obviously magnesium ion is going to replace the hydrogen ion and you're going to get hydrogen gas and magnesium sulfate. Make sure that you do not make the mistake of writing the incorrect formula and all that. So magnesium is positive 2, sulfate is negative 2. You have to remember the ion on sulfate. So there you go. That's the formula and the equation that is balanced. And that brings us to the end of this exercise. You now understand the major concepts of acids and bases, the tests that are usually done, and also the indicators, the colors. How do you know the pH? Remember that pH cannot be measured using litmus or methyl orange because they just tell you the nature of the thing, not the pH. Then we have talked about the major definitions and major reactions. So in case of any confusions, make sure you go over the notes and pass over the question that we have. Thank you.